Hello and welcome back. So I want to look at this last question just in a little bit more detail. So we were told that we have an angle in quadrant 1, and the sine of that angle was 2/5. We want to find the values of all the other trig functions. So we found values for x, y, and r and plugged them in, and were able to compute all of our trig functions. But even though y over r was equal to 2/5, for example, we could say, oh, 2/5, that's the same thing as 4/10. So why isn't y equal to 4, r equal to 10, and x equal to whatever we would need it to? And the answer is, we could have, and we would get this exact same values. So for instance, if we wanted to do 4/10 instead, we could calculate x again. So x squared would be 4 squared, x squared plus 4 squared would be equal to 10 squared. So x squared would be equal to, so 10 squared is 100, minus 4 squared is 16, so that would give us 84. So x would be the square root of 84, and 80 squared of 84 happens to be 2√21. And you can already see that, oh, we've got the square root of 21 in here. So if I wanted to find the cosine of this angle, it would be 2√21 divided by 10, which would simplify to the exact same thing. So when you are working out all the rest of these trig functions, you might as well choose x, y, and r to be whatever these values here are going to be. So for instance, sine being y over r, and we know that that's 2/5. We might as well use 2/5 and not make it complicated by choosing bigger ones. So let's do another example, and I'll show you a little bit more of this as well. So we're going to let the secant of theta be 6, and then we also want the tangent of theta to be negative. So then we want to find the values of the other trig functions. So again, drawing a picture is our best bet. And here we know that the secant of a number of an angle is going to be r over x, and this is going to be equal to 6. So we could have 6 over 1. For instance, r, we always need r to be positive, so it's going to be 6, and x can either be positive or negative, but in this case, this will have to be positive. So the question is, where is y? So we know that if r is 6 and x is going to be 1, well, if x is 1, we know that we're to the right. But are we going to be up here or down here? And this is where we're not told what quadrant we're living in. Are we in quadrant 1? Are we in quadrant 4? Well, we'll have to use this information to be able to tell us. The tangent has got to be negative. So again, the tangent of an angle is going to be y divided by x. And we're assuming that x is going to be equal to 1. And we don't know what y is, but we know that this has to be negative. So our only possibility is for y to be negative as well. So if y is negative, that means that we're below the x-axis. So we're not going to be up here. So we have our point is going to be down here. Our x and y, we're assuming that x is 1. Y we don't know yet. And r, this distance, is going to be 6. So then just like before, we can take x squared plus y squared is equal to r squared, the two sides of our triangle. So we know that this distance is 1. We don't know y. So 1 squared plus y squared is equal to 6 squared. So y squared is going to be equal to 6 squared is 36, minus 1 squared is 35. So y is going to be the square root of 35. And now we have values for x, y, and r, and we can plug and chug. So sine, which is going to be y divided by r, is going to be the square root of 35, that's what I have, over 6. Cosine, which is the reciprocal of secant, is just going to be 1/6, and tangent is going to be y divided by r, so this is going to be 35, I keep writing a 6, square root of 35 over 6. The cosecant will be the reciprocal of this, so it's going to be 6 over square root of 35. Again, we want to rationalize our fractions, so I'll multiply the bottom by the square root of 35, and I'll multiply the top by the square root of 35. The secant, we were told in our original question, was just 6, and the cotangent is going to be 6 should be y divided by x for tangent. I made that mistake. So this should be square root of 35 divided by 1, which is just the square root of 35. The cotangent should be the reciprocal of this, so 1 over the square root of 35, which if I rationalize this, if I multiply the top and bottom by the square root of 35, I get the square root of 35 divided by 35. So that's it for looking at these angles. And what I quickly want to do is look at some identities. There will be an entire section of the textbook that is all about these identities, but there's a couple that I want to introduce now because they may be useful in the upcoming lessons. So we've already seen some reciprocal identities, as in sine is 1 over cosecant, tangent is 1 over cotangent, and things like this. But there are a couple other ones. So if I write down sine of theta is always going to be y divided by r, and cosine theta is going to be x divided by r. What happens if I take sine of theta divided by cosine of theta? Well, I've got y divided by r divided by x divided by r. We know how to divide fractions. This will be y divided by r times r divided by x. We multiply it by the reciprocal. R's cancel, and we get y divided by x, which is the same thing as tangent. So one nice identity is going to be that the tangent of theta is going to be the same thing as sine theta over cosine theta. So if we know cosine and sine, we can figure out tangent pretty easily. And this one's quite nice. One more that I will show you at the moment will stem from the Pythagorean identity. So again, if we have our right triangle with r being the hypotenuse, x being the distance along the x-axis, and y being this distance here, we know that x squared plus y squared is equal to r squared. And now I'm going to do something maybe a little bit silly. I'm going to divide everything by r squared. So divide both sides by r squared. Why? Well, this simplifies into another nice identity. So the right-hand side, r squared divided by r squared, well, that's just 1. Okay. X squared plus y squared divided by r squared. I'll just divide both of these by r squared. X squared divided by r squared plus y squared divided by r squared. And I'm going to pull out this square here, and we'll start to see something familiar. We'll have x squared plus y over r squared is equal to 1. X over r, well, that was the same thing as cosine, plus y over r, That's the same thing as sine. So if you know what cosine and sine, if you know what cosine is, we can square it. We can solve for the sine, and typically this is written in the following way. The second identity would be sine squared, and we normally write the squared right next to the sine. I'm not sure why. Probably so that it's not theta squared, but the whole thing squared. So this is sine squared plus cosine squared is equal to 1. This is just another nice identity. If you know sine, we can find cosine, and vice versa. But we already knew that from our previous questions. So just a couple identities to keep in your back pocket for the moment. This is a nice one: sine squared plus cosine squared is equal to 1, and the other one relates the tangent to sines and cosines.